This video is going to cover Unit 25, Section 2, and Unit 25, Section 3. Okay, we're talking about the circumference formula of a circle. At the bottom of page 615, it says that there's an important relationship that exists between the circumference and the diameter of a circle. If you take the circumference of a circle, divide it by the diameter, you're going to get an irrational number known as pi. Pi is approximately 3.14. Okay, an irrational means that the number cannot be expressed as a fraction, and the decimal repeats and repeats. It never stops, and it never duplicates. Pi, blueberry pie, apple pie. Okay, so with this equation written like this, I can algebraically solve this for C. I multiply D out, and I get C, or circumference, is equal to D diameter times pi. Now, because the diameter is also 2 times the radius, I can replace that and I can say that C is equal to 2 times R times pi. So these are my two equations for the circumference of a circle. Now, most of us might be more familiar seeing this one written as 2 pi r. It is exactly the same thing. There's no difference at all. Now, when would you use one and when would you use the other? Well, it all depends. If you're given the diameter and you're asked to find the circumference, use this one. If you're given the radius, use this one. Now, a lot of times in a shop or something like that, it's not very practical to find the radius, but you can measure the diameter with some tools, and then from there, if you need to, like, let's say you had some bar stock, like that, and you wanted to find out what the circumference of that was. Well, you can get a tool here, measure the distance from there to there, and then you've got the diameter. And then you can use that diameter, multiply it by about 3.14 to get the circumference. So that is finding the circumference of a circle. Now we're going to use that knowledge that we have to help us with 25 section 3 when we're going to be working on the arc length formula. So at the bottom of page 616, 25.3, it says that there are the same number of degrees in the arc of a central angle as they are in the central angle itself. So what in the world does that mean? So there are two ways to measure an arc. Let's talk about arc MN here for a moment. There are two ways to measure that. One is the actual length of the distance from here to here. Another is in degrees. Okay? Now, we also measure angles in degrees. Okay? So what this is saying here is that if this angle were, what does it look like? If this angle were, say, 50 degrees, then this arc MN, would equal 50 degrees. That's what that's talking about. Because like I said, there's two ways to measure. You can measure it with a distance, or you can measure it with degrees. That's what that's talking about. Okay. So when we're talking about measuring the distance of an arc, the length of an arc, what we're doing is we have the circumference formula, and the circumference formula is one of the arcs. Circumference all the way around the circle. That's considered to be kind of like an arc. If I go all the way around this circle here, that's kind of like an arc all the way around. But if I'm only wanting a certain percentage of that, I take the measurement of the degrees, divide that by 360. So now I have a ratio or a proportion of that. I have a percent of that. And then I take that and I multiply that by circumference. Well, circumference we know to be one of these. So I'll just say 2 pi r. So this is the arc length. So this is all the way around the circle. And this is that percent that we want. So that is going to equal the arc length. All right, so let's go to this circle right here. And let's say that the radius of this circle is 7. All right. And I want to know what the arc length is from E to D. And let's say that this angle right here is 80 degrees. Okay, so I come down here and I put my 80 divided by 360, multiply that by 2, and I'm just going to use 3.14 times, what did I say, 7. 7 for the radius. And that's going to give me the arc length. So, fraction bar, where is that? Right there. And I will say 80 in the top, 360 in the bottom. Move it out of the fraction. Multiply that by 2 times 3.14 times 7. And I get 9.77 for the arc length. 9.77. And the units on that will be the same units that the diameter or the radius was in. So if that radius was 7 inches, then this would be 9.77 inches. So that's where the units come from. The units come from the measure of the radius, or if you use the diameter, would be the measure of the diameter. So that is arc length. So what you're doing is you're taking the circumference, which is what this is, and you're multiplying it by a percent of that circumference, which all the way around is 360. We only want 80 of that. So this is a percentage of that. Now we're going to do something similar to this again when we talk about sector and sector areas and areas of the full circle and stuff like that. It'll be very similar situation.